All right, I'm sorry it's taken me a while to get this video online to you, but I hope that now it'll work. All right, I hope you've had a good time with your time off, but you do still have to work because it's not truly off time. So today, what I want to talk to you about is three of the things that I assigned on IXL that deal with powers of rational numbers. All right, and again, exponents, you've been learning, you knew since 5th grade. If I had something like 3 to the 3rd power, you know that the base number is the number you use, and the exponent tells you how many times to use it. Remember in 5th grade when we talked about the little nerdy guy who went to college and the big dumb jock who blew out his knee, so he had to work in a brick factory? The little nerdy guy told the big old dumb jock what to do. So this tells you what you're using, and this tells you how many times to use it. But that does not mean your answer is 333, because what do you do with the 3? You multiply it times itself. So 3 times 3 is 9, times 3 is 27. And again, you've been doing exponents since 5th grade, so this should not be a real problem for you. All right, so what's different now? Now the base number can change, because you could have a -5 to the 3rd power. Again, this is the number you're going to use. The big number, the base number is the number you use. The exponent tells you how many times to use it. So this would be a -5 times a -5 times a -5. So now you need to know how to multiply integers, which I hope you know how to do. A -5 times a -5 is a +25, and then a +25 times a -5 would be a negative 25 carry you 2, 10 and 2 is 12, a -125. So the -5 to the 3rd power equals a -125. Or if you had something like a -2 to the 4th power, again, this is the number that's going to do the work. This is how many times you're going to use it. So this is a -2 times a -2 times a -2 times a -2. How many 2's? 4 of them. A -2 times a -2 is a +4, because a negative times a negative is a positive. A +4 times a -2 is a -8, because a positive times a negative is a negative. And then a -8 times a -2 is a +16, because a negative times a negative is a positive. So your answer is a +16. So what do you notice here? You notice that if the exponent is odd, the answer is negative, and if the exponent is even, the answer is positive. Remember, we talked about that when we were multiplying integers. If you have an even number of negatives, your answer is going to be positive. If you have an odd number of negatives, your answer is going to be negative. The exponent tells you how many negative ones you're going to have. So really, finding a power of a negative base number is really very easy. That's one of the sections in IXL. And I would expect you to be able to get 100% on that, because you know about exponents and you know about integers. Now, you have another section that asks you to find things like this: 2 2/3 to the 4th power. Now, again, how would I do that? Well, now I need to know how to work with mixed numerals and with exponents, because the base number is a mixed numeral and the exponent. So this is the number I'm going to use, and this is how many times I'm going to use it. So 2 2/3 to the 4th power means 2 2/3 times 2 2/3 times 2 2/3 times 2 2/3. And again, you can't multiply mixed numerals, you can only multiply fractions, so you make the mixed numerals into fractions. And what kind of fractions do mixed numerals become? Improper fractions. 3 times 2 is 6, plus 2 is 8/3, times 8/3, times 8/3, times 8/3. Can I simplify before I multiply? Unfortunately not. And when I multiply, 8 times 8 is 64. 8 times 8 is 64. But then I have to multiply 64 times 64. 16 carry you 1, 24 and 1 is 25. 24 carry you 2, 36 and 2 is 38. And you get an answer here of 4,096. And then you multiply 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. And your answer is 4,096 81st. But again, that's improper. So you divide 81 into 4,096. And again, 8 goes into 40 exactly 5 times. 4 would be a better guess. Move back one place. 4 times 1 is 4. 4 times 8 is 32. I didn't guess too big. I can subtract. And actually 85 is too big. I guess too small. So 85 worked. And that's because there was no carryover. 5 times 1 is 5. 5 times 8 is 40. And that would give you a remainder of 4. Bring that to 6. 81 goes into 46 0 times because 81 is bigger than 46. Remainder 46, 81st. Make sure it can't be simplified, which it can, and that's your answer. So 2 2/3 to the 4th power is 50 and 46, 81st. This is not hard, but it's very easy to get wrong because you have all the computation that you have to do with it. But basically, to do it is the same way you do whole numbers and the same way we just learned to do integers. The base number is the number you use, the exponent tells you how many times you use it. And again, they're going to give you another one, like this. Two hundredths to the 3rd power. Once again, the base number is the number you're going to use, the exponent tells you how many times to use it. So what am I going to use here? 2 hundredths. How many times am I going to use it? 3 times. So this means 2 hundredths times 2 hundredths times 2 hundredths. And 2 hundredths times 2 hundredths, 2 times 2 is 4. You have 4 places behind the decimal in the problem. You need 4 places behind the decimal in the answer. So you add 3 zeros. So you get 4 thousandths times 2 hundredths. And that's going to be 8. 1, 2, 3, 4, 5, 6 places. And again, you only have 1, so you have to add 5 zeros in front. Right? And again, that's your answer to 2 hundredths to the 3rd power. Comes out to be 8 millionths. All right? By the way, here's a neat little trick that can help you do this. When you do 2 hundredths to the 3rd power, ignore the decimal and just do 2 to the 3rd power, which is 8, right? 2 times 3 times 4 is 8. But then to find out how many places you need behind the decimal in the problem, take the number of places in the problem and multiply it times the exponent. 2 places in the problem 3 times will be a total of 6 places. And since I only have 1, I can have 3 more. And again, this can get difficult computation-wise too. But the idea behind it is very simple. This is why when I didn't think I could get the video to work, and I told you that you could go ahead and try it without the video. Because it's nothing new. It's what you've already done, but using different numbers with it. By the way, I don't think the IXL does this, but you could have something like a negative 1 1/2 to the square. And again, now we're using exponents with rational numbers. In this case, a negative mixed numeral. So again, it still means to use this number that number of times. So this is a negative 1 1/2 times a negative 1 1/2, which would be a negative 3/2 times a negative 3/2. By the way, a negative times a negative is a positive. You would know that because the exponent was even, it's going to be positive. And then 3 times 3 is 9, 2 times 2 is 4. And and your answer is a positive 4/9. Improper, so divide 4 into 9 goes 2 times, remainder 1, and your answer becomes a positive 2 1/4. And again, whenever you're dealing with exponents, whether the base number be a whole number, a negative integer, a fraction, a decimal, or a rational number, it's always the same. The exponent tells you how many times to multiply the base number times itself. I hope everyone gets 100% on the topics and get to work on it, because that's your assignment.